Students, let us see note on a vector calculus. Before going to note, I will just revise your previous concepts. So in the first video I said all basics of vectors. Okay, all basics of vectors. Next one, definition of scalar field, definition of a scalar field and vector field. That is nothing but only scalar point function and a vector point function. Okay, scalar point function and vector point function in a region R, that is nothing but scalar field and a vector field respectively. Third one, I said about the operator. There are two type of operator. One is the differential operator, another one is the Laplacian operator. This is called a vector differential operator del. This is called as a Laplacian operator. Laplacian operator. Del definition, you know that dou by dou x into I plus dou by dou y into j plus dou by dou z into vector k. Okay. Fourth one, and also Laplacian operator definition, del square is equals to dou square by dou x square, dou square by dou y square plus dou square by dou z square. Okay. Next, fourth one, what we have here, gradient of a vector field. Gradient of a scalar field, not vector field, gradient of a scalar field. Gradient of a scalar field, that is nothing but grad phi or a del phi. Okay, del phi, that is nothing but here dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. This is the definition of a gradient of a scalar field. You have to remember the definition of a gradient of a scalar field. Fifth point, you people have learnt about the divergence. Yes, divergence of a vector field and curl of a vector field. Yes. Okay. So, what is the divergence of vector field? Divergence of a vector field is denoted as divergence of vector A, or another one symbol del dot vector A. Del dot vector A. Del dot vector A is equals to dou A1 by dou x plus dou A2 by dou y plus dou A3 by dou z. This is the definition of a divergence of a vector field. Similarly, what we have here? Curl of a vector field. Curl of a vector field definition, curl A or del cross product with vector A. Del cross product with vector A, that is the ijk dou by dou x, dou by dou y, dou by dou z, a1, a2, a3, where vector A is equals to a1i plus a2j plus a3k. This is the definition of a curl of a vector field. Curl of a vector field, that is denoted as del cross product with vector A, that is the determinant of ijk, dou by dou x, dou by dou y, dou by dou z must be in a second row, a1, a2, a3 in a third row. Okay. Next, what we have? Directional derivative. Directional derivative. What is the formula for directional derivative? Del phi dot product with n cap. What is the n cap? N cap denotes here vector d divided by magnitude of vector d. This is the given. Vector d is the given. That is nothing but here direction. So apply this formula, you will get the result of directional derivative. What is the formula? Del phi dot product with n cap. Okay. So observe here, divergence. Divergence means d. First letter d, then it must be dot product. The definition include here dot product. So next one, curl. Starting letter C is there. So that is nothing but here cross product. So D, here C. D with means divergence, that must be a dot product. Curl means C, that is always here cross product. Okay. So let us see what are the notes here. So observe here, you people are having a problems on a notes. So first note, what we have here, the unit vector normal n cap along a del phi is given by n cap is equals to del phi divided by magnitude of a del phi. There is no derivation on this first note. You had to remember only statement. So what we have, the unit vector normal n cap along a del phi, the unit vector normal, this normal vector n cap along del phi is given by n cap is equals to del phi divided by magnitude of a del phi. Second note, what we have, the angle between the two surfaces is defined to be equal to the angle between their normals. So if they ask angle between the two surfaces or if they ask angle between their normals, you have to apply this formula only. Both are same here because angle between the two surfaces is defined to be equal to the angle between their normals. So consider two surfaces. One first surface equation, general equation, these two. Okay, phi 1 of x1 x comma y comma z equals to c1. Next surface equation, phi 2 of x comma y comma z is equals to c2. c1 and c2 are a constants here. Be the equations of the two surfaces. These two are equations of two surfaces. The angle between these two surfaces is defined to be equal to the angle between their normals. Okay. So what is that formula? Cos theta is equals to del phi 1 dot del phi 2 divided by magnitude of del phi 1 into magnitude of del phi 2, where theta is the angle between their normals. Okay, this is the formula to find out the angle between the two surfaces or angle between their normals. Both are same here. So here one important sub note is there. What is that? Condition for the surface to intersect right angle. If the surfaces intersect right angles, then we have to put a theta as a pi by 2. Put a theta is equals to pi by 2 here. Cos pi by 2 value 0, cos 90 degree 0, then transpose denominator term on LHS, that become totally 0. Therefore finally you will get del phi 1 dot del phi 2 is equals to 0. What it means? If theta is equals to pi by 2, then the surfaces are said to be intersect each other orthogonally. If they ask orthogonally, then you have to apply this condition. What we have? Del phi 1 dot del phi 2 is equals to 0.